Good morning, good evening, and good afternoon, ladies and gentlemen. Yes, I realize I said evening before afternoon. It's been a long day. Well, in today's video, we're going to be looking at adding and subtracting rational expressions. Well, before we go into an actual example of this, I just want to remind you of what would happen when we add and subtract normal fractions. So if I ever did 1 over 2 plus 1 over 3, well, in order to be able to add these two together, we need them to have this common denominators. So, in this case, we have a 2 on the bottom of here, a 3 on the bottom of here. Well, 2 and 3 should both become 6. Why? Because they can both become 6. And that's the smallest, or as you can say, lowest common multiple. So the LCM is 6, which is the lowest common multiple. Because obviously they can both be 12, but that's just too big. We should always go with the smallest you can possibly go. So how do I turn 2 into 6? Well, I multiply it by 3. But whatever I do to the bottom, I gotta do by the top. Because you know the sibling rule. If your sibling, your brother or sister gets $100, you're gonna want $100 too. And I know some people are going to say they want $200, but semantics. How do I turn 3 into 6? Well, I multiply this by 2, which means I multiply this by 2. So that should give me 3 over 6 plus 2 over 6. Now that they have the same bottom, we can just add our tops, which is 5 over 6. Okay? So the same thing usually happens when you're adding and subtracting rational expressions. The first thing you would need to do is to find common denominators. But in order to do that, you need to be able to see your full scope. So the first thing you need to do, I'm going to write them up here, is factor. When in doubt, factorize. So what do we have? Well, can't do anything on the top. Can't do anything on the top here. Can't also do anything on the bottom here. But here, I realize this is a perfect square. This is a perfect square. Minus in the middle, this is a difference of squares. So I can turn this into x plus 1 times x minus 1. Now, in order to find a common denominator, you're going to look at both things on the bottom, and you're going to see what the other one is missing. So what do I mean by what they're missing? Well, in this one has x plus 1. This one also has x plus 1. So I'm going to put a green one here because they both have x plus 1. While this one has x minus 1, but this one does not have x minus 1. So it is missing x minus 1. So the lowest common multiple in this case would be x minus 1. So you're going to multiply the bottom by x minus 1, and you multiply the top by x minus 1. Because remember, you want your bottom to be the same. So let's carry on here. Obviously, I don't need to do anything here. But here, you're going to have 3x times x minus 1. Remember, these have to distribute. So 3x times x is 3x squared. 3x times minus 1 is minus 3x. And on the bottom, you have x plus 1 times x minus 1. So now the bottoms are the same. And just like with fractions, if the bottoms are the same, we can add our tops. So you have 4x plus 3x squared minus 3x. So what are my like terms? Well, I have 4 apples minus 3 apples. Remember, we can't touch this one because of the squared. So I'm going to put that here, 3x squared, because I can't touch it. That's a banana. That's 3 bananas. So 4 apples minus 3 apples is 1 apple, or x, over x plus 1 times x minus 1. Okay? Now, at this point here, so I'm going to write these additional steps up here, so you multiply top, bottom, and the last step would be to simplify if you can. Alright, now in this case here, can I simplify? Well, let me take a look at this. So I'm going to go up here. Well, I realize on the top that they both have x's, so let me take out an x, see what I have. That's 3x plus 1. And on the bottom, can't do anything. So factoring out the x did nothing. I can't cancel anything from the top, can't cancel anything from the bottom, in which case I didn't need to do it at all, which means this would be my final answer. Let's look at one more example. Okay, so this example is a little bit harder. So remember, follow your steps. So our first step is to factor. I cannot factor this side or the bottom here, so we're going to leave this alone. Can't factor the top because it's already most I can do. And on the bottom, perfect square, perfect square, perfect square, minus in the middle. This is a difference of squares. So I can factor this into 4x minus 5, 4x plus 5. So let's take a look. What's missing? What do they both have? They both have 4x plus 5. This one has a 5x plus 4. This one does not. This one has a 4x minus 5. This one does not. So that means you need to multiply the top and the bottom here by 4x minus 5. And you need to multiply the top and the bottom here by 5x plus 4. Which is going to give you, remember, distribute. Got to catch them all. Yes, you knew the Pokemon joke was going to come back. So 6x times 4x is 24x squared. 6x times minus 5 is minus 30x. Now I know they're all going to be over the same thing already anyway, so I'm just going to skip ahead to that because I know they're all going to be above 4x plus 5, 5x plus 4, 4x minus 5. Now remember, this is a minus 5x. Do not forget the minus when you're distributing inside. So it's minus 5x times positive 5x, which is minus 25x squared. Minus 5x times positive 4, which is minus 20x. Alright, so let's find our like terms. So we have here 24x squared, negative 25x squared. So right here we have 24 apples minus 25 apples. Why? Because they both have the squared. Then we have minus 30x minus 20x. They both share the x without an exponent, so these are bananas, which is why I used yellow. All right, so what do we got? Well, 24x squared minus 25x squared, that's basically me saying 24 apples minus 25 apples, which is minus 1 apples, or in this case x squared, minus 30x minus 20x. So you're taking away 30 bananas, you're taking away 20 bananas. How much did you both take away? Well, we both took away 50 bananas. And of course on the bottom you have your whole thing here. Okay, now should I factor this? Will it make a difference? Well, you never know until you try. So let's see. If I factored out, I could factor out an x here. Maybe I could also take out a negative. So let's take out negative x, which leaves me with x plus 50 Well, that was useless. Nothing cancels out on the top with the bottom. So this would be my final answer. So I hope that you have understood these methods and can apply them to future questions. Have a good day.